All right, attempt number two at a fix a random bug in a random GitHub issue. Uh, I've been flicking through the GitHub issue search results, and I found this one, which is quite a bit different than the last bug that we tackled, so hopefully it's interesting. Uh, this bug appears to be a unsupported parameter types for a built-in function, a built-in array intrinsic in lib.fortran. I've never used Fortran ever, um, so should be interesting. But the description of the bug seems pretty simple. I'm guessing that the intrinsic exists, it supports integers at the moment, or numbers, or whatever Fortran's number types are. But it looks like this user is expecting it to also work with strings. So we'll probably have to look up some Fortran docs and see what the right behavior is um, for strings. There's also a pretty good compiler exception going on here that kind of gives us some information about what the internal helper function that might be driving this intrinsic uh, is called. So I think we can probably dig into this pretty quickly. The repository in question is lfortran. It's a modern Fortran compiler built on top of LLVM. I don't do a lot of programming language work, so I'm not like I obviously know what LLVM is, but I've never done a big project that uses it. I think most of the work here is probably going to be in the runtime libraries for lfortran. Like I said, the specific helper function that implements this intrinsic. Um, but if we have to end up digging into LLVM stuff to make it work, we'll see what we can do. The project seems to have pretty good documentation. There's a contributing guide, so I'm not that worried about us being able to get this thing built. Uh, Given the fact that the reproduction case for the bug is really simple, I think we should probably just get things cloned, try get things built, get a file with this, see if we can repro the bug with the command that's given, and then we'll dig into whatever this helper function is and see if we can find what's going on. So without wasting any more time, let's get going. I'm going to actually, uh, this is what I'm supposed to be doing. In the last video, I noticed that the split screen approach didn't work that well, so I'm going to try and keep my terminal and my editor on different workspaces this time so that everything shows up as full screen. And let's find the contributing guide. Fork. I tend to do this the other way around. I fork upstream and then I add myself as a different upstream later. Installation guide. Sounds like all I need. Git and wget. In Ubuntu, you can install binutils dev. Conda. That might be packaged in Arc. But what is Conda? Package management. Okay. I definitely don't have that installed. Fast Conda package builder. conda package, conda shell completions. Anaconda. Okay, I think I saw that. Deployment, as package management and deployment of Anaconda. I would prefer to run something from the AUR rather than doing this. LF. Generate 0, build 1. Active prompt. Okay, let's check really quick and see whether that's how this recommends being installed. In the meantime, I think this Anaconda package seems right, so let's get that going from the AUR and see what we see. Oh, Anaconda is a package manager, and one of the packages inside of it is Conda. So we need we'll see. Linux x86.shell. Is that the same shell script that was referenced? No, this is miniconda. It might not be that different. The 3. Yeah, okay. We'll see. This is a big file. Maybe I should have done the mini one, given that that's what they were recommending. Shouldn't be this. Okay, so this is now referencing Pi312. Is that the same as the shell script that was referenced in their installation guide? No. They're saying latest, but this might be good enough. Then, in this add upstream, where was the installation guide? It was here. Honda env-s underscore Linux. Activate ls. So let's get an editor. I think I already cloned. Nope. Did I not? Oh yeah. Wrong path. lfortran. Environment underscore Linux. Okay, so it's just a bunch of packages that we need. Nothing here seems wild. So let's wait for this to get installed, and we should be able to do the installation, or at least get our virtual environment set up. So does the LF name come from here? Yes, it does. So when we run the conda env create, giving it environment.linux, it's going to create a virtual environment, I presume, based on this YAML file. The virtual environment is going to be named LF, and that's what we activate when we run this command. So that makes sense. Ninja. Okay. Is this? Let's go into lfortran. Does this exist now? No, it doesn't. Any? Enable conda for the current user. Go -f source. Seems reasonable. Ah, okay. So where did it get installed? Mini conda 3. Okay. So the next step was to create that virtual environment. That was here, conda env create -f environment underscore linux.y error conda content trust OpenSSL's legacy provider. Okay, so it says it was a fatal error, but it kept going. Okay, so we need a lot. These look like all the packages that were listed within the YML file, but probably with additional dependencies behind them. In the interim, oh, it's okay. I'm gonna activate lf. Guess I'm just gonna get the SSL error every time. Interesting. This is a persistent thing, so I guess I have to run all commands. Can I still do like other stuff? Yes. Interesting. Outside build 0. Build 1. Right? I need Ninja to rebuild. So okay, so now it's doing the C++ build, so this is gonna take a little bit. Let's see. Debug. Specifically this. What do we got? ASR. ASR underscore utils. Intrinsic array function. Okay. I don't know what lib ASR is. I'm gonna check and make sure that that's actually in this repo. I probably is. It's not like a submodule or anything. Yeah, so what is libasr? Do they have a file here that says what it is? No. Okay. Build's still ongoing. So called intrinsics. What was it called? Called ASR underscore utils. And the function name was get maximum value with given type. Allocator. kind. Extract kind from type. Real. The numeric limits. Max. Integer constant. Okay, so this is kind of interesting. This looks like a helper that's maybe used in evaluation of the get minimum value from the array, that they're initializing the minimum value to the maximum value for the type, which means you can then just iterate through all the elements in the array and check if any of them are less than that value. This is probably a good time to find the documentation for the Fortran intrinsics and see what they are defined to return when invoked with a empty list. Determines the minimum value of the elements in an array value, or if the dim argument determines the minimum value along each row of the array in the dim direction. Mask is present, only the elements for which mask is true are considered. If the array has size 0 or all the elements of mask are false, then the result is huge array. If array is numeric, or a string of char 255 characters, if array is of character type. Huge. So huge seems like it probably translates to the maximum value for the given type. Let's check that. Huge X returns the largest number that is not infinity in the model of type X. Not infinity in the model type of X. That's function. Okay, so we have huge and tiny. But we really shouldn't be X shall be type real, integer, or unsigned. Yeah, so we don't want to extend this helper function, assuming that this is the helper function that backs huge. We don't want to extend this function to support strings, because huge isn't defined for strings, even if we need minval to work for strings. Build done? Build is done. So let's contributing, no, installation. I'm gonna skip tests for now and source bin lfortran. Okay, this gives me a prompt from the bug. What's this? So let's just create test case dot, what was it? L90 was the extension that the bug used, I believe. F90. And I'm assuming that the same thing has the option of running with a file as input. Yes. Wait. Yes. So if I just do this and I run test case F90, I get the exact same error. The get maximum value with given type, not implemented for str. Now, what I'm interested in is from the Fortran docs that we found for Huge, they also had this test program. And if I huge tiny.f90 and I do this prints maximum and minimum values for various types. I don't know why it didn't. Why wasn't that there? Tiny expects real as arguments. Tiny. X shall be of type real. Positive non-zero number in the model. Oh. Okay, so huge is not. Huge is like max val, but tiny is not min val for a type. Tiny is just the smallest value greater than 0. So that makes sense. What doesn't make sense to me. Oh, I see. So real can be both floats and doubles, which is why this works. So I don't really care about this. The point I have is that I should be able to do this, which means that the argument type that I'm passing the kind should be str, and huge expects into a real. And if I go back to the ASR utils.h, get maximum value with given type, this is ASR builder min. Intrinsic array history. Okay. So this does ASR builder min. What are the args here? Initial and then element. Oh, yeah, okay. So the initial value here, this is not what's used to drive huge. That's what it looks like at least. Do they have an instantiate underscore huge? No. Create huge, eval underscore huge. That's in intrinsic functions. Yeah, okay, so this is very similar, but it's different than the get minimum value that we were looking at before. So the get minimum value that we were looking at before is only used for the min-val intrinsic. So we can update this without a problem. Now, min, yes, our builder, min, Make if expression array less than left, right, left, right, left, right. This seems reasonable. Doesn't seem like it requires big change. And similarly for max. So we might be able to get away with just updating this. And the case is just string. And I don't know if I need a kind. What if it's a string? String kind. String kind is an M64. What is stored in it? String 1 was the 1 to the third argument. I think kind is just kind. Value equals 4. What is this? So here in which one was it? It was this one. 1. Yeah, I don't know. Type. Okay. Don't think that kind variable is anything for strings. They're copying it obviously over whenever they copy strings, which means kind of gives them the opportunity to store something in there in the future. But although here is interesting, here we're passing -1 to make string. But nothing explains what mkind is. Strings? Don't see anything that explains mkind. So let's ignore it for now. See what we find moving forward. So given that the array functions registry seems to be the only one calling this, yes, it should be totally safe for us to add string override to here, which is what we were just starting to do. String constant, allocator, location, **, a type, allocator, ASR type, lock, the value is going to be just this. No, it's supposed to be a 255, not a 0. Um, is there anything else that's already making a 255 string and char255 array? What is char255 string of char255? Size or on huge array. So or array is of character type. Does it really work for Fortran characters? Or contiguous strings. Now, what is, if I go back to my, if I do, does this work? Prints nothing. Okay. Back here, maximum, this. Do they call this with winner string? Yeah, they call this all over the place. S2C. What is S2C? I'm looking for something that creates the 255 value. C string allocator. There a that was wishful thinking. That's just mine. So, trying to see if trying to see if there's anything else that references this. Like obviously minval comes up, but maybe there's something else that would have already been implemented that has the right semantics. Doesn't look like it. Let's do. This is probably not a good idea. But let's do. Can I just do Ninja? Here, request remember C string. Oh, I don't. Do I need to terminate this? Not really. Just do. My C++ is not great. See what we find. What's it complaining about? No matching function call for C string with an allocator. I see them calling that all over the place. Thought I did. Allocator, yeah. So if I do, wait, was that the one I just added? No. Intrinsic functions. Intrinsic functions dot h c stra allocator. Ooh. Args. They're integer constant. Equals I. String s value plus string. We get a string. Okay, so this is a different string implementation. So what do? They do this, and they append the character. So even if whatever the integer value is, they're going to be appending. So this is the code that we want, I believe. And then we go to here. This needs to come here. We don't need this. We just need s from, then we do s string allocator. I think that'll build. Now that only will work if the 255 string compares above every other string, and I'm not sure if it will, but the question is, how do we create a string that has like multiple 255 characters in Fortran, which I'm gonna have to figure out how to do that, because that would be an edge case that I'd be worried about. We're basically saying something like min val equals char 255 for element in array if element is less than min val equals element. Return min val. And this only works if min val is actually initialized to the maximum possible value for a string. Now obviously 255 is the maximum value for a character, but what happens if one of the elements in the array, I don't know Fortran syntax, so I'm making this up as I go, but what if it's two 255 characters after each other? Is this going to compare as bigger than this? If it does, then we're going to have to update the definition of instantiate R intrinsic, I believe. Okay, so this is done. So now we can do this case. And it did something. It didn't error out anymore, but it didn't print anything. So when we do min val, we get the max val. So can I do print star a is less than char 255? False. Is greater than? True. So I'm calling min val right now. Min val. Bring up 255 characters. If dim is absent, or if array has rank of 1, the result is a scalar. If dim is present, the result is an array with rank 1 less than the rank of array. Class corresponding with the dim. In all cases, the result is the same type and kind as array. A. But this is false. Fortran string comparison. String ordinal comparison. Fortran string ordering. Seems unlikely that their definitions of min are wrong. Left then. It's a string. Make string compare. Left greater than. Greater than. Oh, less than. String compare. Turn n. And compare. Okay. Less than. This seems weird to me. Mm. Value argument with the smallest, most negative value. In A1, A2, A3. Type shall be integer, real, or unsigned. strings. Min. So it might be useful for me to install a different Fortran interpreter just to do a sanity check on whether the values that I'm getting are reasonable. Okay, so lfortran is what they recommend. Flang. GCC Fortran. This maybe just find reference, transfer character. AF. When did that get written? 6 minutes ago, so that's not the GCC case. Do I just have G Fortran? Is that different than... Oh, yeah, it's different than lfortran. Okay, so maybe that's what I want. Is this compile? That's probably going to create a.out, right? Create a.out? Yes, it does. ATA. Okay. So G Fortran creates returns T. Okay, so it seems like the issue might be bigger in that the less than operator doesn't work for strings in the right way. Let's how do I do comments in Fortran? strings. Okay, so if I do this and this and run this again, I get F, and I do I get T. Okay. So first off, I'm going to go back to the bug. I think one of the things I want with this series is I want to clearly, I want to set expectations. You know, I'm pulling a random bug off a random project. There's a fairly good chance that I'm not going to be able to solve the bug that I'm looking at. The goal of this series is not to say, oh, hey, I can pull a random bug and I can fix it. I think a much more clear goal is I can pull a random bug and I can make progress. I can get an environment set up, I can reproduce, I can, you know, start going down the debugging path, and sometimes I'm going to be out of my depth. But in this case, I think I can come back and basically say, hey, it looks like there's more going on here than the original bug. And that seems, you know, like I'm contributing in a useful way, even if I haven't fixed the bug. So I'm taking a stab at this bug. It originally looked like a fix might be as simple as returning char 255 in the get maximum value with given type helper. However, even after doing this, it looks like the minval intrinsic isn't returning the expected value. I did a quick check. It seems like there is a more fundamental difference in the string comparison implementations between lfortran and gfortran. So string comparison.f90, this, you. Yep, that makes sense. So program string comparison. What's a source bin? lfortran string underscore comparison.f90 returns f, and with lfort gfortran string comparison.f90 and a.out returns t. Going to dig a bit more and see if I can find out why these strings are comparing differently. And so, like I said, just this, I think, is something that I would treat as success. I don't know this project. I've never worked on it. I don't even know the language that I'm working with. And so just being able to kind of come in, get the project running, and find out something more than was originally on the bug. I think this, to me, is success. Um, Obviously, I hope that I can find out more than this and push this even further, but I'm happy with this. So I'm going to publish this comment, then I'm going to go back and see if I can figure out what's going on with string comparisons. So the min intrinsic was generating the right value, if I recall. Let's try that again. Min print min so is this just because I did this? Yes. Okay. Glad I tried that. I could have spent a lot of time wondering why that wasn't working. Okay. So in both cases, min returns true. I have to figure out why the less than operator is different than the string comparison that's being done in the min intrinsic. Because I believe when I looked at intrinsic functions, this is doing eval min. This is just straight up doing a strict comp in the min intrinsic, which is, this seems like the correct implementation, whereas the other path that I was following, which was using intrinsic array functions minval, no, using ASR builder min. So ASR builder min is different than intrinsic functions min. Make if left is less than right, return left. If left is greater than right, return left, otherwise right. ASR utils expert type left. So this seems right. It seems really unlikely that this is just wrong in all cases. Like it's probably something related to strings. If I do min.f90 and I do min int.f90, like I'm guessing they would have caught this. The formatting's way different, but regardless. Oh wait, min was correct in both versions, right? Yes. So this is what I should be trying. T. So it seems really likely that there's not something wrong with the logical implementation of less than. It seems much more likely that there's something wrong with the specific string comparison that's being done when the types are strings. So let's go back to ASR Builder and the left then implementation. Now, is it a string? Probably. That was greater than, less than string. I don't know if this is going to work. So min was good. String comparison is where I'm getting the difference, right? So let's see. No response. This guy opened the bug an hour ago. He seems like he's pretty involved in the project, so he might be online. He might be working on this same bug right now. But that doesn't mean it's not a good opportunity for me as well. The C++ build takes just long enough to be a little frustrating, but it should be okay. It's also relatively likely that string comparisons are going on all over the place. I wonder, I should actually test whether, yeah, it didn't even print. Uh, could be a number of reasons, probably just because it's a interactive interpreter or something like that. But let's run Ninja again, but let's change our string comparison.f90 to print something other than the char 255 case. So if I do this, it's TNT. I wonder whether this is right in both cases, or wrong in both cases. What I would like to do in the meantime, though, is the ASR builder makes this logical string compare expression, which I don't quite understand how this gets implemented. How do they know what's being done here? Comp up string 0 SR to CCPP. Where is it? String compare true binary op case self dot replace string compare. Is this actually generating C or C++ and then compiling? What is this doing? Generate element-wise operation. This has to be for element-wise. This has to be for arrays. Yeah, array op. Okay. So I don't think that's Yeah. Okay, so the comparison works for um, this case. Uh, F AT type of. Integer, real, complex, logical, and character. So can I do um, one 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 one? Okay. Is that different than this? Okay. So let's go back here. And is this actually running, I guess, is the interesting thing. Because I did see a different implementation when I looked at the min intrinsic. Intrinsic functions dot h circle. LGT. This was min. And this was if it's less than 0, then the min val is equal to val. So if it's less than 0, then val is less than this. And in this case, if it's, this is, and I'll compare. Um, does it actually generate? I don't know if it's actually going through this path. Like this is the implementation of that string comparison operator that I'm seeing, but it doesn't. I'm surprised that this lfortran works this way if it does. So let's try at the same time look at other references to string compare. String compare. I don't see anything that says it's printing or generating, and I'd be surprised if it was, but array op. Oh, getting into lowering and more codegen level stuff, which, because this would make sense for the minval case, but it doesn't really explain the this case. Like this case, I would expect shouldn't be going through like an array lowering path to SIMD intrinsics or anything like that. So let's keep looking. Like this should just be the less than operator, but the less than operator was converted to a string comparison. A string comparison well, this should be easy to check at least, because this is in array op. Replace underscore string comparison. Can I replace this with anything here? None of these are really obvious that I can replace it with. Plus, when I was in the sorry, till what was it? It was array intrinsics. Expression, array size. Like this makes sense for the min-val function. It just doesn't make sense to me for the unary comparison case. What was the it was libasr intrinsic functions cpp min-val create underscore min-val, and it called intrinsic array function registry. Find min-val. Being used, right? It's used for reals. This is totally different than what I was looking at before. Why? Product min-val. I feel like this is the first time I'm seeing this. This is what I did see. This min-val. Function min-val. Create min-val. So this must be for different paths. But the part that definitely matters here, like this is the one that's going back to the actual if expressions and the LT, and this is still in libasr. Make string compare. Compare op type less than. Logical from. A value. Can I yeah, it just seems like type creation of something expression visitor JSON block. lfortran. Julia to Python to WASM. To const. Maybe. Isn't null pointer x unconst? X dot base. This pass replaces initializer expressions with evaluated values. The function pass replace param to const transforms the ASR tree and in place. Okay, so this could be what's going on. Yeah, because at least in the sample program that I'm using, the values are constants. So let's hold on to this for 1 second, and I'm gonna try and read input string. Okay. Just first 5. I'm not sure. Star a second. And star first is less than second. First. A. T. If I do no file found with given unit. um lfortran read line. Optimization. D-G. Do-show C. Oh, yeah. Okay. A beat is less than 0. Oh. A less than 0. So char 255 is an empty string. In this case. With string comparison again. Okay, so char okay. Okay, so it prints wrong. Let's do this. Prints ttdt. This is what I wanted. There is a character there. If I do uh 100. Yeah, fortran string length. Len char 255 1 and 1. Really? The show C result definitely doesn't seem to indicate that that should be 1. Um, fortran intrinsics.h dash I force libasr runtime. Okay, there are things here. The console's just not showing them. But when I cat them into a file, they are there. Okay. But still, oh no, okay, so this explains my whole thing that it's generating an empty string is just not right. The strings are getting generated, my console's just not printing them out properly. So that was a red herring. What I can still do though, what are the other options here? Is there a, like a, disable optimizations? Dash G. So the path that I was looking at was ASR tree visitor. So H. Wait, no. What I was looking at. Where was I looking at when that walk visitor? One. It was in ASR to. It was param to const. Pass replace param to const. What does this get called? It gets called in place param to const. why it wouldn't take me here. H. Nothing's calling this? Doesn't look like it. Okay. ram to const.cpp and oh, genpass.py. Okay. I don't do Python. Dash. Okay. This genpass isn't getting run, so let's just go to place ram to const pass and do this and just do this. And see what happens. Also going to check back, just see if any comments on this. Doesn't look like it. E, F, T, 111, TT. Okay, so it's not not an issue with constant folding or anything like that. That's my understanding from this, at least. So the string compare implementation. Yeah. So let's go back to looking at string compare references and see what we can find. ASR to Fortran, Python, ASR to what? Array op simplifier. Base array. Is there a overall code that, or overall function that creates this thing? Same thing. Do this. basically just going pass by pass and seeing what changes the result. Still F. Okay. Probably not that. So back to string compare, and can I? There a dump ASR option? Show ASM. Show show ASR. String constant. Intrinsic elemental function. R integer constant 255. Okay. Now I also saw in here there was an option for dump all passes. So let's do an input. Pass undump. Okay, that didn't work. Is in lfortran.cpp. If pass options, dump all passes are for pass underscore JSON. S underscore. Ooh. Okay. At the very end, you have string constant A, string constant Y, and the LD just doesn't work. Like nothing here seems wrong, right? Um, um, ET. What was the actual result? F. Just on the last one. But that basically means like it has to be the implementation of LT. That's somehow wrong for a case where a string contains 255. So, and the op here is still string compare. So we're doing the right thing, looking at references to string compare. Yeah. What are the pass names here? Simplifier goes way earlier. So it doesn't seem like it's one of the passes. It's got to be after the passes. And an array op. It's not an array op though. It's just scalars. Bin op or member case. Extract member. Okay, that doesn't seem useful. String compare. Left. Op right. Type. Table entry type. Expression value. Return value is the expression. Lexicographically less than or less. Except strings. Are string compare string constant is greater than string constant e. That makes total sense. Everything there aligns with what I've already kind of figured out. I'm just trying to figure out how this gets lowered, I guess. Place Pollock. Okay. Um, ASR to LVM has to be what's actually being done at the end of the day. Is it expert wrapper? Okay, so this is if constant has already produced a previous pass. So what we should actually do is we should check the pass 31 again, and is there false? Logical constant, false. Does this mean the pass has already produced the value? I think so. Okay. That brings in like the string folding case again. But here it's folded to true. So let's see, actually, going back to passes, let's see if there's a place where one of the passes hasn't generated this value yet and the next pass has. So at this point, we already have the logical value at pass 16. So just doing a binary search through the passes. And even at pass 8, we already have it. So just gonna keep going. Pass 4, we have it. 2, we have it. That's 1 we don't. Okay. That's 2 we have it. So the initial pass already has the result. So we're really looking like for a Fortran to ASR. Mod to ASR. AST to ASR. String compare. I don't see a string compare here. But it is here. This is interesting. I should ASR2 text. Is it JSON? Not really. To isn't print ASR print dump. It's what was the pass manager? It was in lfortran.cpp. Dump all passes. Pickle. Sure. Sure. Okay. String compare. Hmm. I, I think this is right though. So let's go back to that mod to ASR CPP. And what is this? Procedure. This is really small. For to ASR till no. It could just be AST to ASR though. Um, Fortran AST. And so this pulls out to some other pass ASR to Fortran. To ASR, which is the file that I'm in. Body visitor. Is this generated? Body visitor. Body visitor. File big one? Yes. Value here is null pointer. Oh. Okay, I don't know what advance is. Doesn't seem right, but this is the only case. Generate string compare. Lower string const. Add file expression. Oh. Right. For node. Binary. Can I dump the AST? Oh, AST. print 0 less than string A func call or array. Okay, so it's a LT. E then is it if arithmetic? Less than a binary operator. AST.h is probably a big file. Read AST type unit mod import case. It's expression, I guess. Struct expra underscore t. AST type class type equals type expression. AST underscore t base expra type is going to be bin op. Is string compare here? No. So let's go back to body to ASR. FT body visitor. This is the one that needs to generate ASR. I think this is where it was bin op. Logical bin op. Visit. No visit underscore bin op. No. Visit expra. Yes. Okay, visit binop. But AST to ASR. Is in AST source to JSON. Common visitor.h. Binop is 146. No, that's the helper. 647. Is it ASR utils expression temp? Okay, so visit binop 2 definitely, because the left right temp binop to string. Okay, this. Okay. Add some mul div pow. Am I totally wrong? Op equals op, which operator type? Not what I want. I need pop type. Is it comp? Compare. Common visitor methods visit compare. Descriptor string. less than. Okay, so we get the op. Then we do left type, right type, left type, right type. Type is string. If left type isn't real and left type isn't integer and right type isn't real, right type isn't integer, and left type isn't complex, or right type isn't complex. Strange that this is, and op equals eq string, or right type isn't string. Okay, type equals right type, source type equals left type. Find conversion candidate, that converted value. Good. Left dims, array dimensions, make logical. If x per value left isn't null pointer and x per value right isn't null pointer. Comp time values, populate comp time values, evaluate comp time values, ASR op left right. This seems very likely where we need to be. So if compile time values dot size equals 0, no, args dot reserve time values left val first, right val second, pair helper, pair helper. If is integer left, is real left, complex left, logical left, string left. Char star left equals downcast for the left value, char star right. ASR utils remove trailing white spaces. Why? This could be the issue. Equals comp equals left string dot compare right comp. Result equals true less than. Yeah, seems likely that this is going to be the issue. This seems very odd to be doing at this point in the program. So let's do and just see what we get when we do this. This is a good point. This code was added not that long ago. I think it's not showing the commits now because I changed the lines, but I might be able to. Still false, and we want it to be true. and still generate the passes. Let's see what this generates. It's still a logical constant false. Okay, I was relatively confident we'd figured it out. I was gonna assume that remove trailing whitespace wasn't handling the 255 characters correctly. Now, bit of a shame that I haven't been able to get. Oh, ring, ring. This could still be problematic, though, actually. Um, 255 is not null terminator. Um, um, I can never remember. They're they're not going to be that long, but I can never remember the format strings for printf. I don't do this often enough. Let's just see what's passing through here. If it's getting to this point, this seems like a pretty likely case for what's going on. And this was only called when we had values for both left and right. So, seems likely. Oh, 1A. Right now. 1. It's supposed to be true. Or not. Structure shouldn't. So we're getting a string length of 1 for both of them. T result I strong. Once again, check if I've gotten any responses to that comment, just in case somebody's going to help me, but I don't think so. Old result, 88. Which, yeah, would not indicate. Which indicates that it's not, um, not less than. Indeed. So something very strange is happening here. Um, uh, right valve row first. Right valve first char. Because the value that we're getting here should be 255, I believe. But the difference between A and 255 should be negative. It shouldn't be positive like this. ASCII table, what is the value for lowercase a? It is 141. So it's -1 because they're unsigned, or because they're signed, and it's less than. So should we be doing these comparisons as unsigned chars? And so this basically means that it can boil down to a simpler case. I think we actually have a I should have tried this earlier, but I think the interesting thing is we should just be able to do this. In comparison. ETT. E. EF. 127 less than less than 5. Give it a, am I doing off by 1? $255, we get -1. Why do we not get that for anything else? EFT. 240. What is the covert point? Yeah. Yeah. This is very strange. -1. -1. First char, -1. Now they're all coming back as F. Um, oh. -56. I was looking at the wrong print. -31. Now it's producing the right value. It's producing the wrong value. Right value, wrong value. T F. So the issue here is just that the extra comp treats the characters as signed, and that's what lfortran is using throughout the project for string comparisons. And gfortran seems to do unsigned comparison. Fortran character signed. Is always unsigned. Is there a string? String a thing? No. And character defined on a 2-byte boundary if it does not appear in a data statement. Okay. Fortran char unsigned. Fortran data types. Character type. So I think I'm almost ready to write another comment. The Oracle one didn't support deep linking, so one string is lexically left. In general, lexicon comparison differ from corresponding. Fortran character unsigned. Okay, this shouldn't have taken me that long. I should have noticed, like I know that char is a signed type, and the fact that the gfortran produced less than true should have immediately indicated that the comparisons that were being done were unsigned. And I should have immediately realized that almost any usage of strcomp was not going to be reasonable. But I don't actually know if that's the case because I don't know, like the Oracle post here says that character types are always unsigned. But I don't know if that's actually the specs that this specific project is going for. I don't know Fortran well enough to know if treating characters as signed is just totally wrong. So I'm probably going to write up a comment here with my findings, and then probably stop and wait for somebody to respond. At least with my understanding of the issue so far, fixing this would require replacing every usage of strcomp throughout the project with something else, at least with the intent, and any time it's used with the intention of comparing character data. I don't think that's particularly hard, but I think it's too big of a change for me to go into a project like this with without the owners or maintainers acknowledging that that's something that needs to be done. So I think I'll write up what I can and probably end the video here and see maybe the project maintainers come back in a few days and they have more insight. So I kept digging into why the string comparisons were producing inconsistent results. The constant value associated with the a less than char 2.5 expression is generated in common methods during generated during AST to ASR conversion in the two strings val have the correct data, but the dot compare call they are being compared using string compare. String compare treats the input characters as as signed values, whereas the lfortran semantics seem to compare characters as unsigned. I did a small amount of searching, but I'm not familiar with Fortran's specified behavior in this case. I found this. It's that character values should always be unsigned, but I can't find other references that say something similar. If character comparisons should always be unsigned, it looks like there are many calls to strcomp throughout this project that are likely producing incorrect results when using characters with integer values greater than 127. For example, ASR2C. ASR2C conversion generates strcomp calls for string compare expressions. I didn't want to make a sweeping to string comparisons across the project before checking in to see what the would be. Okay. I should have maybe checked here for unsigned. Yeah, I don't see a bug that's obviously tracking that current behavior. So I think at least the comment I made is not missing some known state in the project. Regardless, like I said, I think I would treat this whole session as a success. I figured out kind of how to implement the original min-val max-val helpers. I think the original implementation that I had for those a couple hours ago would have been correct. Should have worked if the string comparisons were working the way that gfortran implements them. I also think I found like a really interesting potential challenge within the project that its behavior doesn't match gfortran, and yeah, I think I've contributed meaningfully to the bug. I think I've helped. If the owner were to respond to these comments, for example, I think I could potentially push this forward. making the string comparison changes across the project is probably a pretty large task, um, given all the different backends that they support, Julia, Python, etc. Um, and making sure that the results are consistent would be a challenge. But nevertheless, like I said, I think this is a success for me. I'm happy with how this went. So thanks everybody, and that's where I'm going to call it.